warahmatullahi wabarakatuh. So this video is for the revision of selected quizzes starting from quiz 10 until bonus quiz. So here, not all quizzes will be discussed. I only select some of the quizzes, and furthermore, as you know, for some quizzes, sometimes I may have two sets of questions, so I select one set of questions to be discussed, but then the whole sets of questions, even if the the value in each of the questions could be different, but then the concept of, the way to answer it is just the same. Okay, so now let's look at the first quiz. The first quiz is quiz 10. So we look at the first question here. Let me use red pen first. Given that m is actually the function of w and s, given by this, find derivative of GWS when the value of W is 1 and then S is 2. Okay, that's how you read the question. So it is 5 marks. Okay, now if you see here, first you need to understand the question. The question is asking you to find the derivative. Yeah? And what kind of derivative? It is mixed partial derivative. How do we know? Because from here, you can see clearly, first you need to find the derivative of this function m with respect to w. After you get the first derivative of m with respect to w, then the answer that you get, you differentiate it again, but this time around with respect to s. Okay, so this is mixed partial derivative. After you get the final answer, then you substitute the value of w equivalent to 1 and the value of s equivalent to 2 back into your answer to get the final answer. Okay, so how are you going to do it? So let me rewrite again the question here. Okay, so let's say m is equivalent to, g w as a function of w and s, which is equivalent to w s squared plus, ln 2s squared. Okay, all right. So we know that we need to find this, yeah, GWS. So first we need to find GW. Okay, it's actually equivalent to this, yeah, delta M over delta W. That what it means. Okay, if you don't write this one, it also okay, but I just want to explain to you what does it mean by this sign. That's all. Okay, you see here we have W before. We have two parts. The first part is this, the second part is this. Before and after plus sign of this function. So let's differentiate the first part here. Because you see W is here, S square is here. Because we want to differentiate W only, not S square. So S square is considered as a constant. Like, S square is like 5, 10 or something like that, like a constant. So when you differentiate it, then you differentiate it like this. So it becomes W, when you differentiate it, becomes 1, isn't it? And then you have S square. Alright, so it becomes S square. So even if you don't write 1 here, it's okay also. Okay, and then differentiate this. When we want to differentiate this with respect to W, do you see W here? When you don't see W, that means the whole, expression here, we consider it as constant. So when you differentiate it with respect to W, it becomes 0 because no W is there, isn't it? So as a consequence, your answer is this. You get me? Okay. Now next, we need to find the final answer because the question says you need to find GWS. So now this answer, you differentiate it again, but this time around with respect to S. Do you see S here? Yes, you see. So you can differentiate it. So use the rule that you have learned in derivative. This is power rule, isn't it? So now, power rule, 2 here, it becomes 2. And then S stay S. So we have 2 minus 1, isn't it? So it becomes s to the power of 1, or simply s. So that's the answer. Okay, now, finally, because it says that you need to find GWS, okay, when the value of W is 1 and the value of S is 2, then how do you find it? We know that 2S. Do you see W? No W here, isn't it? So you don't substitute W equal to 1 back into here because you don't see W. But let's say your answer has W, you just substitute W equivalent to 1 here, that's all. Do you see S? Yes. So now S is 2, substitute it back into this answer, then you get 4. So that's how you get the final answer for this question. Okay, it's done. So we are done with question A. Now let's go back to this quiz. Question 1. Yeah? Now let's go back to this quiz. Question 2. Using Rx equivalent to this expression, find the derivative of the above function and evaluate it at x equivalent to 200. Interpret your answer. What is the economic term for the derivative of the above function? So this is the first thing that you need to find. This is the second thing. This is the third thing. So there are basically 3 different parts of questions for question 2. So you need to find the derivative of Rx here. That means you need to differentiate this function with respect to x. And then after that, once you get the answer, you need to substitute, x back into the answer, x equivalent to 200 into the answer, and then, solve it, get the final answer. Once you get the final answer, you interpret your answer. After that, you need to understand what is the meaning economic term for this derivative. Okay, now let's do it one by one. Let me rewrite again this function here. Rx equivalent to 300 plus 3000 over 2x plus 2 plus 80x minus 1500. So the first part of the question, find the derivative. So it means we need to differentiate Rx. Okay, let me erase a little bit. Yes, there is a mistake. With respect to x. So you need to differentiate this with respect to x. So we have 2 parts. You see here, this one have x, this one has x, this one doesn't have x. Okay, so let's differentiate this one first, and then this, and then this. Okay, if you see this, 3000 is a constant. On the denominator, we have x. Alright, so basically, how do we differentiate it? It becomes 3000, okay, divided by 2x plus 2. Initially, it was the power of 1, isn't it? Now it becomes power of 2. Okay? Alright. And then you differentiate inside here, becomes 2. But then, alright, this bit is to the power of 1, isn't it? But it's on the denominator. And then it becomes minus 1 here. So basically, how do we do this? Okay, let me show you again before I write this one. Yeah. Actually, before I can do this, usually when I was a student, what I do is that I can rewrite this function into becomes this function before I differentiate. And basically what I'm doing now is not actually answering the question. I'm just simplifying my equation so that I can easily do the differentiation. This denominator can also be rewritten as 2x plus 2 to the power of minus 1, isn't it? And then I rewrite it, this one again, 80x as usual, and then 1500. Do you get me? So this bit, let's say you have this 1 over x. It's also equivalent to x to the power of minus 1, isn't it? So same goes to this. If you have 2x plus 2, 1 over 2x plus 2 is equivalent to 2x plus 2 to the power of minus 1, isn't it? So that's what I'm doing here. Okay, then we can differentiate it. Differentiate Rx with respect to x. Also, you can also write it this way. R prime x. Either one of these is okay. Okay, either one of these is okay. Now, then, if I want to differentiate the first part of this function after the equal sign, then I have 3000 constant. Then I differentiate this bit. You see minus 1 here? You can use chain rule. Okay? So you have minus 1, bring it here. We write again this expression, 2x plus 2, close the bracket. Now what happens to minus 1? Minus 1, minus 1. Okay? And then you differentiate the one inside the bracket, because the one inside the brackets you have 2x plus 2. So when you differentiate 2x, it becomes 2. When you differentiate 2 here, this one, it becomes 0, isn't it? You get me? Alright? So I have differentiated the first part. Now I move to the second part after the plus sign. After the plus sign, you have 80x. When you differentiate it with respect to x, it becomes 80, isn't it? What about the last part, minus 1500? Do you see x there? No, you don't. Then it becomes 0, isn't it? Okay. Now I can simplify it further. So it becomes minus 3000, okay, 2x plus 2 to the power of minus 2, okay, times 2, isn't it? And then plus 80 minus 0. If I simplify further, then I can get this minus 300, minus 3000 over, I can change this back to the to the denominator position. So it becomes 2x plus 2 to the power of 2 or square plus 80 minus 0 minus 0. Then that's the derivative. So we have answered the first part of the question, that is this one. But we haven't answered it fully because we haven't evaluated it at x equivalent to 200. So now what should we do? Okay, so we should substitute x equivalent to 200 back into this answer to get it evaluated. So let me do it here because I don't have enough space in the previous slide. So I have r prime x equivalent to minus 3000 over 2x plus 2 to the square, okay, plus 80. So when I have r prime x 200, then I have minus 3000, okay, 2 times 200 close the bracket, square, plus 80, then you get the answer here. This one I'm sure you know how to calculate it yourself, yeah? Okay, so that's for question 2. So we are done with question 1 and question 2. Now we need to move to question 3. Okay. Let's look at question 3 now. Okay. Given the following demand function for product A and product B, where QA and QB, and also PA and PB. Oh, I forgot one thing. Yeah, I haven't actually answered the whole thing here for question 2. I forgot to answer second bit and also the third bit of question 2. Let's go back to this. I'm sorry about that. But anyway, so if you get the answer here, whatever value here, okay, whatever value here. So here, I expect you to calculate it yourself, but let's say I'm just making up, but this value is not correct, and I'm sure you know the right answer for this. Question, for this bit of question. Let's say the answer is 100. Let's say I'm just making up. This is not the correct answer. I want you to find it yourself, calculate it yourself. But let's say I'm just making up. It is 100. So the second bit of the question here says, interpret your answer. So how do you answer it? Okay. So if you see this, basically, Rx. In economic study, usually we use R for the term of revenue. Okay, this one you should, if you do exercises from the textbook and whatnot, then you know what does it mean. Again, that's why I don't really put the term in from the beginning, the the early part of the question. Okay, so here, how do you interpret the answer? Let's say the answer is 100. If you see the value 100, it means positive sign, isn't it? So that means if x increases by 1, then r prime x increases. Why increases? Because positive sign, positive 100, equivalently to 100. Okay, but the precise way to answer this is because by right, I told you just now, R in economic study is basically revenue. X here then refer to quantity of output. Okay, if X or quantity, this is how you interpret the answer. Yeah, if X or quantity increases by 1 unit, then revenue will increase by 100. Let's say 100 ringgit, why not? We don't say 100 unit, yeah? That is very general. Why do we say ringgit? Because revenue usually in terms of money form, isn't it? Okay? So that's how you interpret it. And therefore, what's the economic term for the derivative of the above function? In other words, what does it mean by this Rx in economic study? It means marginal what? Marginal revenue. That's it. Okay. All right. Now, let's go back to this question. Given the following demand functions for A and B, okay, so we have demand function for A, demand function for B. Okay, determine the relationship between product A and product B. As you can see from each of these demand function, this is the first one, the second one. The first one is demand function for A. The second one is demand function for B. The first one, if you see the first one here, it depends on the price of A itself and also the price of B, good B. Okay, so if I write the generic function, QA is actually depending on PA and PB. Can you see? Theoretically speaking, if it depends on price of A or price of the good itself, then we're talking about the demand curve. But here, this is not the only determinant of the demand for A. There are some other determinant for demand of A, let's say the price of other good, let's say price of B. If you can recall back the study of economics, some other determinants could be income, could be weather, could be many things, could be, natural disaster and many things. Okay, this one you have learned it in principle. Okay, now, once you can understand this, is very easy to find the answer. If you want to see the the relationship between product A and product B, using the equation here, the best way to answer it is by finding the derivative of demand A with respect to price of B. That means what happens to the demand of A if price of good B changes? Then we can see the relationship, isn't it? Same goes to this, the second one. What happens to the quantity of B if price of A changes? Okay, so you need to find these two derivatives. Okay, so how do we do it? Let's do it here. Let's say I rewrite again, demand for A equivalent to, I'm just rewriting it back here because rather than, going back to the previous slide, it may as well I write it here so that it's easy for my reference. So here, 600 divided by BB plus 1. Okay. You see this one, we have fraction. Usually when I was a student, to avoid mistakes, I rewrite first QA as this. Okay, 5,000 minus 50 PA minus 600 in bracket. I make the denominator here becomes just the same line with 600, then PB plus 1, because it's power 1, then it becomes minus 1. Then once I wrote it, I already wrote it this way, then I start to differentiate it. You can also straight away differentiate it, but I prefer to do this because when I was a student, I had tendency to make mistakes when I don't write it the second way here. I haven't done the derivative, I just rewrite the equation into the simpler way that I think could help me to answer this question. Remember, the question asks you what's the relationship between product A and product B. So we are dealing with the first equation first here. So I need to differentiate QA with respect to PB. There is no point to differentiate QA with respect to PA. What's the reason? Because you are not answering the question. That's why for some student, when they do it, then I deduct the mark, because you see here, determine the relationship between product A and product B. It doesn't ask you determine the relationship between product A and price of A. It doesn't ask you determine the relationship between product B and price of B. No. It is asking you between QA and product B. So you look at the price of B. Between product B and product A. So you look at the price of A. Don't look at this one. For the first one, don't look at this one. You get me? So here, let's do the first one. Delta QA over delta PB. Any B here? PB here? No. So it becomes 0 when you differentiate, isn't it? Minus any B here, you differentiate this, it becomes 0. Okay? Minus any B here, yes. So you have 600 constant, because multiply 600 still appears here. And then PB plus 1, you can use chain rule to differentiate this. So rewrite again PB plus 1. This minus 1 power, it becomes, you bring it here, minus 1. It's actually similar to this, remember? You see this? Minus 1. Minus 1 here, minus 1. Do you get me? Alright, so let's go back to this. And then after that, you differentiate the 1 in the bracket. You see PB? You differentiate it, becomes 1, isn't it? 1 here, you differentiate it, becomes 0. You get me? Okay. So then the final answer is minus 600 times minus 1. Okay. PB times 1, isn't it? So it becomes 1. Minus plus, isn't it? 600 PB. But I forgot one thing here. This one minus 1 minus 1. Then we have, okay, here PB plus 1 minus 2. How do we rewrite this? Here, then I can write it this way. I mean this way. But then it becomes PB plus 1 square. No longer minus, because you already changed it to denominator here. Okay, so you can see here plus, this one plus, this one, sorry, I made mistake here. Yeah, sorry. Can we start again? It shouldn't exist, this one, sorry. Because when you differentiate PB here, it becomes 1. Okay, so that's the correct one. Okay, let me re-explain it to you again. This one 0, this one 0. Now this one, minus 600, okay, minus 600. Multiply by, inside the bracket, you rewrite it again, PB plus 1. The power here, minus 1, minus 1. And then, okay, minus 1 here, you bring down, you write it this way. And then you differentiate the 1 in the bracket here, PB plus 1. When you differentiate PB plus 1 here, it becomes 1 plus 0, because PB, when you differentiate it, becomes 1. Plus 1, you differentiate it because it's a constant, you don't see PB. When you differentiate it with respect to PB, it becomes 0. Then the answer here is minus 1 minus 600, okay, 1 because you differentiate PB, and then this one. Then you can rewrite it this way, but then no longer PB here. Yeah? It's a mistake just now. Okay, you get me? But then we have another equation, QB as a function of PA and PB. This one, QB as a function of PB and PA, isn't it? Okay, so you also need to differentiate this, yeah? Okay, how do we do it? Let's do it here. Like I said, I prefer to write it this way first. QB, rewrite the equation, so 10,400 over minus 400 over PA plus 4, isn't it? Plus 400 PB plus 4. I rewrite the equation first before I differentiate. Then it becomes 10,000 minus 400. The denominator, I change it. PA plus 4 minus 1, isn't it? And then plus 400. Then I change this one. PB plus 4 to the power of minus 1. Do you get me? Now, we need to differentiate it with respect to PA. Don't differentiate it with respect to PB because we don't want to see the relationship between quantity of B and the price of P. We want to see the relationship between quantity of B and the price of A. Okay, so you see here, do you see 10,000? Do you see PA? No. When you don't see PA, what rule of derivative differentiation you should use? Constant rule. So it becomes 0, isn't it? Okay, minus, because minus here. Now, you see the second term here after minus sign. Do you see PA? Because we want to differentiate it with respect to PA. Yes, you see. Then you should differentiate. 400 stay the same because it's a constant multiplied by this term. So that's why stay the same here. Rewrite again the one in the bracket, PA plus 4. But this time around, you see this? Minus 1, minus 1. You get me? And then after that, you differentiate the one in the bracket. You see PA here. When you differentiate it, it becomes 1, isn't it? You see 4 here. Do you see PA? No. It's a constant number because you don't see PA. You differentiate it, becomes 0. Constant rule, isn't it? Okay, done. Okay. But then next, plus sign, plus. You see here, do you see PA? So you don't see PA. So the whole thing here considered as constant. So what happens? When you differentiate delta QB with respect to PA for the third term, it becomes 0. Okay, do you get me? So finally the answer here is, okay, I forgot one thing here. I always forget. One thing. You come again here. Let's look at the second term here, this term. 400, 400. Correct, isn't it? PA plus 4, I rewrite it again. Okay. Minus 1, it becomes a minus 1, minus 1. Differentiate it again here. 1. But I forgot that minus 1, after I rewrite it this way, minus 1 here, you bring it down, it becomes minus 1 here. Okay. Alright, clear. So now it becomes what? 0, 0. I don't have to rewrite it again. Minus 400 meets minus 1. PA plus 4 in bracket minus 2 and then 1. Isn't it? So I can rewrite it. Minus meets minus 400. This one becomes PA plus 4 square. 1 is 1. Okay, now we have two answers now here. The first one is, The first one is this. Okay, delta QA over delta PB. The first one is this. You need to determine the sign of your answer or derivative so that you know the relationship between A and B. You see the plus here, you see positive here, isn't it? So the whole thing here becomes positive or greater than 0. Okay? What about the second derivative that we have found? If I write it again here, delta QP over delta PA, you see this one? Positive, isn't it? Positive. So the whole thing here is greater than 0, positive. Once you see positive sign for both of them, for the first one here, and the second one here, it means what? The relationship between QB and PA is positive. That means if price of B increases, okay, price of A increases, because we have price of A here. Quantity of B increases as well. So if you look at the first one here, also the same thing. If price of B increases, quantity of A increases. Can you see? So what can we say about A and B? Because both of them moving the same direction, that means if price of A increases, means price of A becomes relatively more expensive, people demand more of B, isn't it? And vice versa. So what's the relationship between A and B? It seems that both of them are competitive, or another term we can call them, they are substitute. That's the relationship between both of them. Okay, I hope this is clear, yeah? And one more thing, let's go back to the first question. In the first question, we did this. Find the mixed partial derivative of GWS. I add another question here so that you can do on your own. Why don't you find this? Find GSW12. Okay? Find the mixed partial derivative, but this time around, you differentiate with respect to S first, and then only with respect to W. Do you think you're going to get same answer? Alright? Be careful, yeah, because this time around, you can see natural log here, how to differentiate it. So please do this one. It's not all the time the answer of this will be the same as the answer of this, yeah? Remember that. So not all the time, that's why I want you to try and check whether the answer will be the same or not. But I just want you to try this so that you can try different, way of doing mixed partial derivative. Okay? So we are done with quiz number 10. Alright. So now let's move to quiz 11. So in question 11, we have here the demand equation for a product is represented by this expression P equals to 100 times square root of 1 over 2Q plus 1, where P denotes price and Q denotes quantity. And A, what is the total revenue for that product when price is 20? B, find the elasticity of demand when price is 20 and interpret your answer. Okay, so you have find the elasticity, and second one, interpret your answer clearly. Okay, and C, at P equivalent to 20, classify the demand as either elastic, inelastic, or unit elastic. Justify your answer. Okay, from your answer in B and C, okay, what will happen to the total revenue if price increase? Explain your answer. Okay, let's look at question A first. What is the total revenue for the product when price is P? For A, okay, we know clearly that the total revenue formula is price times quantity. So here we have price, so it's equivalent to 100 times square root of 1 over 2Q plus 1, and then you times Q. So this is the price, and then you times Q. So in general, you're going to have 100Q times square root of 1 over 2Q plus 1. Now, so the price here is actually P times Q, isn't it? So when the price is 20, you need to find Q first. Okay, so price equivalent to 100 times 1 over 2 plus 2Q plus 1. Okay, let me rewrite it somewhere here rather. Okay, so this is the total revenue function, but in order to find price, P equal to 100 times square root of 1 over 2Q plus 1. We rearrange the equation first in order to get the Q, or we can just simply put 20 here as price, 100, and then 1 over 2Q plus 1. And then you rearrange it. So when you rearrange it, okay, I write it here. Okay, so 20 over 100. Because we want to find Q first, then we can only put it back into total revenue function that we have created earlier. Okay, so 200, and then you have square root of 1 over 2Q plus 1. And then continue further. You multiply both sides of this expression. Okay, you square it. So it becomes 220 over 100 square, and this one becomes square root of 1 over 2Q plus 1. You square it. Okay, actually this is also can be written as this. So 20 equivalent to this, yeah, 1 over 2Q plus 1. Square root here can be written as 1/2, and then because you square, you multiply by 2. So this one is actually replacing the symbol of square root, that's all. Okay, now I move to the next page because I don't have enough space now. So what do we have here is that, okay, so you have 400, isn't it? Because 20 square becomes 400. And then the denominator you have 10,000 because 100 square becomes 10,000. And then here you becomes 1 over 2Q plus 1. 2 over 2 becomes 1, isn't it? Okay, so here, instead of writing this way, I write it this way because 2 over 2 is 1. This is what I mean. This one is actually 2 over 2. Okay, this one. Alright. Now, so you simplify it further. So we have 400. Okay, cross multiply, we have 2Q plus 1. Then we have 10,000 here. Okay, so 800Q plus 400 equivalent to 10,000. 800Q equivalent to 10,000 minus 400 equivalent to 9,600. So Q is just simply this, equivalent to 12. That's it. So what's the total revenue? We can simply plug in back into this equation, or because we already know the price, there's another way also. Okay, P times Q is in it because we already know the price. 20 times 12, you're going to get 240. That's the answer for part A. Alright, now B. Find the elasticity of demand when price is equivalent to 20 and interpret your answer clearly. Okay, I rewrite again the equation here, yeah. The equation of demand given by 100 square root of 1 over 2q plus 1. Here you can see clearly price as a function of q. And we know that the formula for elasticity eta is actually delta q over delta p times p over q. Okay? P over Q, you know this one equal to 20, you know this one equals to 12 based on your answer in A. So we only need to find this one. But we are given as price as a function of Q. But this one is delta Q over delta P. That means you can get this derivative if your function is actually Q as a function of price, isn't it? Let me change the notation here. Okay. Q as a function of price. But the one that you are given here is price as a function of Q. So what should you do? You have to change it. You have to inverse it. Okay, you have to inverse it first. So when you inverse it so that it becomes Q only here and then the rest number and price. You get what I mean? Okay, so here we need to do that one first. Once we get that Q as a function of price, then we can get delta Q over delta P. Then we plug in into this formula to get the elasticity value. Okay, so how do we do it? Here, from this equation that is given in the question, we need to rearrange it such that only Q on the left hand side and the rest on the right hand side. That's what I mean. Once we have Q on the left hand side and the rest including P on the right hand side of equal sign, then we can find derivative of delta Q over delta P. Okay, so how do we do it? Cross multiply this, then you have P over 100, you have square root of 1 over 2Q plus 1, in it. Okay, next, you square both sides, it becomes P square over 100 square equivalent to this, isn't it? This one, square root, I change it to this, yeah? And then I square it because the left hand side, I square it, so the right hand side, I should square it also. So it becomes what? This one becomes 1 over 2q plus 1. I hope you get why it becomes like this, because 2 over 2 for the power becomes 1. And then this one, p square over 100 square, in it. Okay, then, okay, let me erase this one. So here, I continue here because I don't have enough space. Then I can have cross multiply 2q plus 1 equivalent to p square over, 100 square over p square. You get me? I'm doing this one by one, and in fact, I can just jump some of the steps here, but because some of you are very weak in mathematics, so I have to do this. And it becomes, okay, 2q plus 1 equivalent to 10,000 over p square. 2q equivalent to 10,000 over p square minus, okay, 1. So q equivalent to 10,000 over p square over 2. Get me? So when you simplify it further, you get something like this. Q equivalent to 5,000 over p square minus 1. That's it. Once you have this, then you can differentiate Q with respect to P. Okay, let me rewrite again the elasticity formula. Delta Q over delta P times P over Q. Okay, so what should we do? This is the demand function that we get after we reinverse it. So this one you can see clearly, it is Q as a function of P, isn't it? Okay, so what should we do next? Delta Q over delta P. You see here 5,000. You see this one? It's actually, before I go to the to the solution of delta Q over delta P, I can actually rewritten this function into Q equivalent to 5000 times 1 over P square minus 1, isn't it? Now you see here, you have constant here, you have this. We just need to differentiate it with respect to P. Okay. Constant is a constant. 5000 still the same because it's multiplied by this variable P. You see P here. So when you differentiate it, it becomes what? Minus 2. Okay. To the power of P. Times P to the power of minus 3. Isn't it? Okay. And then minus 0 because you don't see P here. Alright. So now when we simplify it further, it becomes minus 10,000 again over P cube. Okay, over P cube. Once you get this, you plug in back into this answer. So you have here minus 10,000 over P cube times P over Q. Can you see? Alright, now let me, if I put the line here, okay. So I'm basically from here to here. So this P cube, this is P, I can simply change it to this. Okay, so it becomes minus 10,000 times P squared times Q. Then you plug in the answer. Okay, and here, what do you get here is that, okay, minus 10,000, sorry, yes, minus 10,000 times, okay, 20 square and then 12. You get me? Okay, that's it. Alright, so here, once you calculate it, you're gonna get answer equivalently to, if I write it clearly here, yeah, because I don't have enough space, then I put it here because I don't have enough space. So here, 20 square becomes 400, isn't it? So you can simplify it even further. Then you're gonna get something like minus 2.0833. Ignore the minus sign. We just want to see this. Why do we have to ignore the minus sign? Because minus sign just show you the negative relationship between quantity and the price of the good itself. And that one is basically law of demand. So if you go back to the question, you can see clearly that we need to find the elasticity and then interpret your answer clearly. You have found the elasticity value, which is 2.0833, but you need to interpret it. How do you interpret it? This is where many students got it wrong, because the right way to interpret is like this. You have to interpret the value that you got here. So the value that you get here, you know the minus sign shows you the relationship between price and quantity demanded. So what does it mean? In order to interpret it, this is the way we interpret it, yeah? When price increases by 1%, okay, but you have to write in full sentences here. I just write short form because I'm not, attending the quiz or attending the exam. In the exam, you have to write the full sentences. When the price increases by 1%, not 1 unit, yeah, 1%, so quantity demanded decreases. Why do we call it decreases? Because of the minus sign that we get here. Decreases by 2.0833%. 2.0833%. That's the answer for the interpretation. That's it. Okay, that's the answer for the interpretation. That's it. Okay, so here we are done with question A. You have answered the first part, which is minus 2.0833. The second part, increase in price by 1%, decrease in quantity demanded by 2.0833%. Okay, done. Now, look at question C. At price equivalent to 20, classify the demand as either elastic, inelastic, or unit elastic. Justify your answer. Okay, your answer for elasticity minus 2.0833. Ignore the minus sign. Okay, then you have, because in the textbook, they put minus here also, isn't it? So when you see here, all right, that's why when you have minus here, then you put minus here, then the answer becomes positive. But here I didn't put because I just want to see the sign here. You get what I mean? When I see the sign, then I know that the relationship is negatively related. But you can also put this here. So it becomes minus, minus, positive, positive. Okay, now here we want to decide whether it's elastic or inelastic. So because I put, minus just now, then it becomes positive. So when it becomes positive, we just look at the value, regardless whether you have minus sign or not. We just look at the value. The value here is actually greater than 1. Okay. Alright. The value here is actually greater than 1. If it is greater than 1, that means the increase in price is, the increase in quantity is even more than the increase in price in terms of percentage, isn't it? You can see clearly based on the interpretation, if price increases by 1%, quantity demanded decreases by 2.0833%. Decrease here, that's why we have minus sign earlier, isn't it? But the value here, the value is more than 1. That means here 1, here more than 1. That means it is elastic. So that's the answer. Classify demand as elastic or not. Elastic, the justification, because the elasticity value is more than 1. That's it. That's the only way you answer it precisely. Okay, we move to D. From your answer in B and C, what will happen to the total revenue if price is increased? Explain your answer. When it is elastic, it's very clear that, okay, if you study economics, you know for sure that in the elastic region, if total revenue, when you increase the price, quantity demanded decreases, but the percentage of decrease in quantity demanded is even more than the increase in price, that means the person, the individual, is very, very elastic towards the change in price. We change the price just by 1%, the way the person or individual reacts is even more, because the way he changed quantity is even more than 1%. So he is very elastic. So you know that when you increase the price, total revenue will decrease. That's the answer. That's how you explain it. So if it is inelastic means the answer here should be less than 1. So that means total revenue, the person is not very responsive, isn't it? Not very elastic. So if you increase the price, the change in quantity demanded is not more than 1%, not very responsive. So you can simply increase the price. Quantity demanded not increasing more than 1%. So your total revenue still increase. That's for answer inelastic. But your question here now, you know that the answer is elastic. So total revenue decreases. Because of what? Because the consumer is not very responsive. As we know that because consumer is very responsive, because we know that the percentage change in quantity demanded is even more than the percentage change in price here. So total revenue will decrease. Okay, so that means if you know that the person is very responsive, very sensitive to the change in the price, there's no point thinking that if you can increase the price just because you want to increase revenue and then profit. They will run away from you because they will feel that it's too much. The price increase is too much. You get what I mean? That's what happens when it is very elastic. Okay, so that's the answer for D. Okay, so we are done with question 11. Now let me check here whether I have the answer. Yes, because I thought that I haven't interpreted the answer for question 2. Okay, now we are done with question 11. Now we need to move to quiz 12. Okay. Quiz 12. A bakery bakes 2 cakes, cheesecakes and chocolate cakes. If M is the number of thousands of units of cheesecake and W is the number of thousands of units of chocolate cake, then the cost and revenue in thousands of ringgit Malaysia are the first one is the cost and the second one is revenue. Now, before I proceed with question A and question B, I found out that so many students got it wrong. Yeah? You know why? Here, they thought that the first one is revenue function. No, you look at the question and the cost and revenue. So the first one is cost, the second one is revenue. And because of the wrong understanding, then they got the wrong profit function. Okay, so here, find the number of each type of cakes that should be baked to maximize profit. So you need to find the number of chocolate cake and cheesecake, and this one how many, this one how many. Because cheesecake here is M, how many M? Because chocolate cake here is W, how many W? Those are the things that we need to find. But before we can calculate those things, we need to find profit function because the question is, those number of cakes should maximize profit. How to find profit function? I'm answering question A. You know that profit is actually revenue minus cost. So this one is cost, this one is revenue. So be careful, yeah, because if you interchange it, you think that this one is revenue, this one is cost, then the whole thing will be wrong. Okay, find the profit function. So here, P equals to revenue. You write revenue, 10M plus 16W, and then you minus. Minus, you put in bracket, and you rewrite the cost function here as this. Put in bracket 4m square minus 4mw plus 2w square minus 14m minus 20w plus 11. Close the bracket. Now, you want to simplify your profit function. Rewrite again 10m plus 16w. Open the bracket. Open minus 4m square. Now, minus 4m becomes what? When we make minus, because we open the bracket, plus 4mw. Okay, w is there. Minus means plus. Minus 2w square. Minus means minus becomes plus 14m. Minus means minus becomes plus 20w. Wait a minute, yeah, because there's a mistake in the way I write it. Okay, so plus 20w, and then minus means plus means minus 11. That's it. Be careful with the plus minus sign, and this is where students always make mistake. So some students, they didn't put the bracket, they just write minus 4m square minus 4m. That's wrong. If you want to put back the original cost function here, make sure you put the bracket. When you open the bracket, it changes the sign of plus minus, as you can see here. So then after that, you can simplify it even further. So simplify it even further. You're going to get this, yeah? 24m. How to get 24m? 10m plus 14m, isn't it? So, and then minus 4m square, and then plus 4mw, and then minus 2w square, and then plus 36w. Make sure you know how to get 36w, and then minus 11. So this is the answer for your profit function. I hope this is clear, yeah? Okay, so next. Okay, next, we need to answer the rest of the question. But let me do this first. Okay. Okay, so next question, it says what? So we have found the profit function. So we haven't solved the question of how many M, how many W. Once we found the profit function, what should we do with the profit function? We need to find the FOC, the first order condition of the profit function. How many first order condition? Because we have two cakes. Cheesecakes for M, chocolate cakes for W. So we need to do two first order conditions or FOC. So here how we do it. Maximize profit FOCs. Why I put S? Because we have two FOCs. Okay, but before that, because here we are in different slide, may as well I write back the profit function so that you can always refer to this profit function in this slide rather than going back to the previous slide. So our profit function here is 24m minus 4m square minus 4m square plus 4mw minus 2w square plus 36w minus 11. Okay, then we proceed to the next step. Maximize profit P, okay, FOCs. Okay, FOCs because we have M and W, so we have to do it twice. Okay, first we do it with respect to cheesecake, which is M. So delta P, delta M. We differentiate profit function with respect to M. What do we get? So we're going to get 24. You see this one? Okay, and then we differentiate this, becomes minus 8m only. I hope by now you know how to differentiate this. And then plus, you see this one? You have m here, so it becomes 4w. Because w is not differentiated, it becomes constant. Okay, and then minus this. Do you see anything, any m? No, it becomes 0, isn't it? And then this one, do you see any m? No, so it becomes 0. Also 0 here. And then because it is FOC, equate it to 0. Otherwise, it's not called FOC. We are not maximizing profit. Profit usually, if we do it like this, or whatever here, maximum is here. So when it is maximum, you see the flat line here. The flat line here shows you that the slope is equal to 0. Delta P over delta M is the marginal profit with respect to M, with respect to cheesecake. So when we equate it to 0, it means we are maximizing it at this top point, at this, peak point. Is it clear? All right. So this is number 1. Number 2, you redifferentiate P profit with respect to W. So what do you get? 4M minus 4W plus 36. Equate it to 0. Otherwise, we don't call it FOC. We don't equate it to 0 from the first line. You only equate it in the next line, like what you did in your quiz here. Then it's totally wrong. Okay? Now, here, I just want to simplify this so that I don't have to say many 0 here. Okay. So, equal to 0. This question, expression 1, expression 2. Now, you solve this. Find how many M, find how many W, okay? When you solve it, I don't want to show it here to you because by now you should know how to substitute M and W, how to do a simultaneous equation. You should get M equivalent to 15. You should get W equivalent to 24. Okay? Once you get this, go back to question. You see B, calculate the maximum profit. In order to answer B, what should you do? Okay, you rewrite again the profit function that you calculated earlier, which is 24m minus 4m square plus 4mw minus 2w square plus 36w minus 11. You know that your m you found earlier is equivalent to 15. You know that your w that you found earlier is equivalent to 24. 24. You plug in back into this 24, 15 minus 4, 15 square plus 4, 15 times 24 minus 2, 24 square plus 36, 24, isn't it? Minus 11, then you get the answer. That's your profit. That gives your answer for B. Clear? Okay, so that's it for quiz 12. Quiz 12 is actually easy, except that if you still don't know how to do differentiation. Okay, so where is the question? So that is for quiz 12. I hope this is clear. Before I forget, I would like to go back to this question, question of elasticity, which is this. Okay, which is this. Here, let me erase this. As you can see here, the equation given to you, the demand equation, is inverse demand function. Why do I say inverse? Because here it is price as a function of Q, where you can see clearly P equivalent to 100 and then times square root of 1 over 2 Q plus 1. And then you have to reinverse it to get this, the derivative, isn't it? In order to calculate the elasticity, I mean, you have to reinverse it so that you can calculate delta Q over delta P, isn't it? What if the question given to you like this? Let's say this. Q equivalent to 2p 1 half to the power of 1 half or square root 4 plus p. You can see clearly here it's no longer price as a function of Q, but Q as a function of price. This is a direct demand function. So from here, you can easily get delta Q over delta P without inversing it, isn't it? So here, you go straight. You don't have to inverse it like what I did earlier, which is this. Remember, I have to change it to Q as a function of P. This one is Q as a function of P. Then only I can do delta Q over delta P to be reinserted into the elasticity formula here. But if I give you like this kind of question, with this kind of equation, you don't have to do that anymore. You just go straight to delta Q over delta P. Once you get the answer, insert it back into the elasticity formula and you proceed. Why don't you do this? Let's say, instead of this equation, change it to this and then redo A, B, C, D here. Okay, and then try to redo it. So this is another additional exercise that you can try at home today before the exam. Okay, now let's go back to this. Sorry. Yes. I don't want to discuss quiz 13 because quiz 13 is more or less like quiz 14, except that in quiz 14 you can see the additional part is you need to construct the bordered Hessian matrix. Okay, now let's look at the question first before we look at the answer. Okay, the question says what? The question says, given the following production function in which Q as a function of 800 L to the power of 0.7 times K to the power of 0.3, where L is the number of labor units, K is the number of capital units, Q is the number of production. So here, suppose that labor cost is 70 ringgit per unit, capital cost is 30 ringgit per unit, and the total cost of labor and capital is equal to 100. Okay. A, find the number of units of labor and the number of units of capital that maximize production. Check your answer by constructing the bordered Hessian matrix. B, find the maximum level production based on your answer. Okay, here you need to understand the question first. You have production function, call it Q. Q is actually the number of product you produce, and in order to produce Q, you need labor and capital. Insert into this production function, then you can get Q. Okay, so this is production function. Okay, now, but in order to produce, you also need to buy labor and capital. So there's a constraint there, and the constraint here is in terms of cost of production. It says that labor cost or price of labor is 70, price of capital is 30, and then the budget you have is only 100,000 ringgit. This one, all of them in terms of price. Okay, so that means how many labor, how many capital you produce, you buy, and you use to in production process, the total cost must be equivalent to 100,000, cannot be more than that. So this is the constraint. Okay. You look at question A, find the number of units of labor, how many L, and how many capital then that can maximize production. So you want to maximize production, but with limit of cost. How many production of Q you can produce here? That's the question in B. Okay, so let's do it one by one. For A, you need to construct the objective function first, and then you construct the Lagrangian function. Okay, you have maximize Q equal to 800 L to the power of 0.7 times K to the power of 0.3 subject to cost function. So what is your cost? 70 L. Okay, price of labor times quantity of labor plus 30 K. Price of capital, which is 30 times quantity of capital K, must be equivalent to 100,000. Next, you construct Lagrangian function. F lambda Kn is equivalent to what? Equivalent to objective, and then you write this plus lambda. Like I said in the lecture, you come with 100,000 first, and then you minus 70L minus, because here in bracket, if I write it this way, if I put plus, you should put bracket close. You get what I mean? Okay, so if I rewrite it clearly, then it becomes in bracket, open the smaller bracket, 70L minus, because minus plus plus minus 30. Okay, close the bracket because we have the whole thing here. So this is our Lagrangian function. You must set up clearly the Lagrangian function. Set up like the way I set up it here. In the textbook, of course, they put plus and then plus, isn't it? But I prefer you to use this so that you don't have problem with plus minus sign when you do first order condition and so on and so forth. Okay, next. Using this, you need to find first order condition. In this case, your first order condition is you want to maximize production subject to constraint here. Now, once you combine production and constraint into one function, call it Lagrangian function, it becomes unconstrained function. Okay, so how do you do it? Let me put it here. Let me rewrite again the Lagrangian function that I have constructed earlier. So here, f lambda kl equivalent to 800 L to the power of 0.7 K to the power of 0.3 plus lambda 100,000 minus 70 L minus 30 K. Okay, we want to maximize production, which is F. Okay, that means we are trying to find FOCs. How many of FOCs? You have lambda, you have K and L, so you must get 3 FOCs. So this is capital F here. Okay, so the first FOC, FL, or you can also write it this way, delta F over delta L. Okay, which is what? Here you have L to the power of 0.7, bring 0.7 here, rewrite again 800 because it's a constant. So L now becomes 0.3 minus 0.3. Why? Because 0.7 minus 1 becomes minus 0.3. You get me? I hope you get it by now. Because we don't differentiate k, k stay the same. Okay? Make sure you know how to get minus 0.3, yeah? And then here plus lambda. This one no L, you don't have to differentiate, it becomes 0. This one it has L. So when you differentiate, plus meets minus, minus, rewrite again lambda 70 and then L gone. Okay? Equals to 0. I hope you understand how to do this. This one is actually equivalent to minus lambda 70 L. When you differentiate, it becomes minus lambda 70. That's why you get this. You get me? Okay. The second FOC is equate it to 0, yeah, from the beginning when you do the derivative, because if you don't start from the beginning, it's not called FOCs. You must write this, otherwise it's meaningless. Okay, I can deduct mark. Okay, alright, so FK. Also, you can write it this way, delta F over delta K. But if you don't want to write it, it's okay. You can write this way, or you can write this way. You can write both, also depends on the availability of time in the exam. Alright, now equals, what do you get here? So you want to differentiate K now, L constant, 800 constant. So you bring 0.3 power here, and then you have 800 as usual. L stay the same, isn't it? Because we don't want to differentiate L, L become a constant. So K now becomes what? K to the power of minus 0.7. How do you get this minus 0.7? Because 0.3 minus 1. And then minus lambda, this one we don't want, this one we don't want, because you differentiate becomes 0. So we want to do this. So similar to this one also the same thing, minus, okay, lambda 30, equal it to 0. The same concept as this, eh? You get me? Okay. Okay. Now, I want to erase this. Alright. So the third, FOC is F subscript lambda, or you can write it delta F over delta lambda. The problem with this pen is it tends to, make delta becomes a different thing. Okay, so here you differentiate this bit. Okay, this bit. So here it becomes 100,000 minus 70 L minus 30 K equated to 0. So I number it. This is number 1, number 2, number 3. Okay. So here, from 1, you see here, from 1, I can write it this way. Because 0.7 here times 800, okay, it becomes what, 560, yeah? So I write it this way. So from 1, okay, then I can have here 560 K 0.3 over L 0.3. Okay, minus lambda 70 equal to 0, isn't it? So this one is actually from 1, yeah? From 1 FL. Okay. Make sure you know what I'm doing here. Why L becomes is situated on denominator? Because initially L was to the power of minus 0.3. You can bring it to the denominator, becomes this. Okay. From here, you can rearrange it further. Okay, then you get something like this. Okay, 560K 0.3 over L 0.3, isn't it? And then now, lambda equivalent to 560 over 70 cross multiply K 0.3 L 0.3. And then finally lambda equivalent to 8L 0.3 over, wait a minute, yeah. So basically, wait a minute, because there's a mistake there. So actually there's no mistake. So I rewrite it here. It becomes, okay, here becomes, there's a mistake, sorry. This one shouldn't be K. Shouldn't be L. Should be K. Okay. And then L here. Okay, so I call this number 4. Okay. Now I can also do the same for 2. From 2, which is this, I can also rearrange it like number 1 just now. So let me rearrange it. From 2, so we have Fk, isn't it? Alright, equivalent to what? If you see here, you have 0.3 times 800, it becomes 240, yeah? So it becomes 240 L to the power of 0.7 and then K to the power of 0.7 minus lambda 30 equals to 0, isn't it? Rearrange it nicely like this one. Okay, then finally you're gonna get lambda. I'm skipping the step, but you can't, yeah? You do the same concept like this, then you can get lambda equivalent to 8L to the power of 0.7 over K to the power of 0.7. I call this one 5. Okay, I call this one 5. Wait a minute, the eraser is not working. Okay, alright, now I call this one 5. The eraser is not working well, but anyway. Okay, okay. Well, it's not very sensitive anymore. Alright, slowly we have this one equivalent to 5. Now, what should we do with 4 and 5? We can equate 4 and 5. Equate 4 and 5. So what do we have? 8K 0.3 L 0.3 equal to 8L 0.7 K 0.7. Some student, what they did was, they didn't do this. They, instead of this, they equate lambda equal to lambda. So they did something like this. Alright? So this is wrong. Why do you need to equate lambda equal to lambda? Because they are just the same. It's like, why do you need to equate 5 equal to 5? In fact, that's why there's a need to write equation number, yeah? So you equate 4 to 5. You don't equate lambda to lambda, 5 to 5. What's the point? It's just, it's nothing. It's meaningless. Okay, now what you can do with this is that you can clearly see 8 and 8. I do it one by one. By right, I can just simply, cancel. But I know some students, they have problem with this. Okay, you look carefully. K 0.3, I cross multiply this, it becomes plus 0.7. Okay, and then this one I cross multiply. Okay, then it becomes L 0.7 plus 0.3. You get me? So here, I move to this. So it becomes, wait a minute, yeah? Then I'll show you something more important here. Here, 8 and 8, you cancel. K 0.3 plus 0.7 becomes K to the power of 1. Same goes to L, isn't it? So as a consequence, okay, it becomes K equivalent to L, isn't it? Now, K equivalent to L, I call this one equation 6. Now, what we can do is that, remember, our objective is to find how many K and how many L to maximize profit. So, finally, you have K equivalent to L for equation 6. what do you need to do is substitute 6 here into 3. Where is 3? 3 is this one. This, differentiation of lambda, first order condition of lambda. You substitute back into this, then you can get, how many K, how many L. So let me rewrite it here. So because 3 is like this, 100,000 minus 70L minus 30K equal to 0. So let's substitute K equal to L here. Let's say, because L is equivalent to K, so I just simply put K also, because it's this, isn't it? Minus 30K equal to 0. Then you solve it. You solve it mathematically, show the step. Finally, you're going to get L equivalent to 1000. So what about K? K, because since, equivalent to 1000 because of 6. 6 is L equivalent to K, isn't it? This one. Okay, so you don't have to recalculate, put it back into this equation 3 just to find K, because this is what you found earlier. So you have L and K. And now we have found L and K, but then you need to see here, check your answer by constructing the bordered Hessian matrix. If you can recall back, in the quiz, I kept telling you that before you find bordered Hessian, try to find B first. Why? Bordered Hessian takes longer time to do. But if you see B, the question B here, find the maximum level of production based on your answer in A. You already find L equivalent to 1000. You already find K equivalent to 1000. You just need to find maximum level of production. You know that production function is this one. You know that process of getting Hessian, bordered Hessian matrix takes time. Solve B first, then you straightforward, you can get 2 marks. So let's say we solve B first. You give some space for A, so that you can do bordered Hessian. So let's say I do this. So because previous slide, I was doing question A, so I leave some space for question A. I move to question B first. Okay, so I have some space for question A, then I move to question B first, then I come back to question A. So question B, you need to find maximum level of production. I rewrite again production function, Q equivalent to 800 L to the power of 0.7, K to the power of 0.3. So I know that L is 1000 from previous question. K is also 1000. What should I do? Plug in back into production function. So I get 800 times 1000 to the power of 0.7 and 1000 to the power of 0.3. You can see clearly the base is the same. So that means 800 times 1000 to the power of 0.7 plus 0.3. So it becomes 800 times 1000 to the power of 1, isn't it? So what happens here? Simply 8,100. That's it. Okay, now let's move back to question A, because we haven't found the bordered Hessian matrix, just to check whether we really have maximized the production by using 1000 L and 1000 K for the production of 800,000 Q. Okay, so here, in order to do that, you need to do bordered Hessian. Okay, recall back, bordered Hessian is given by this. Okay, so let's say we have this 0 here, and then you have C here, CL, the first derivative of cost function with respect to L, and then the first derivative of capital function with cost function with respect to K, capital. So here, so CL, CK. So here, small letter F, yeah? Or let me make it this way. Q and L are diagonally Q, K, K. So here Q and K, here Q, K, and close it. Cost function that we have is 70L plus 30k equivalent to 100,000, isn't it? Production function that we have is 800 times L to the power of 0.7 and then K to the power of 0.3. So recall back those things so that it's easier for us to do the calculation. You look here, most of the students made a silly mistake by having what we call CL here by differentiating the lambda, equation 3 here. So that's why they get, instead of 70 for CL and 30 for CK, they got minus 70, minus 30. That's wrong, eh? You differentiate both the Hessian matrix. The element here, you differentiate cost function, not the FOC function. You get me? You also differentiate the production function inside here, not the this. So we're just differentiating the some portion of Lagrangian function. That's what I mean. Okay, you see here. So first you need to find CK, CL. So let's say CL first. CL is actually delta C over delta L. In this case is 30. CK is actually delta C over delta K. In this case is actually 70. Okay. Once you found this, you can plug in into this, bordered Hessian matrix. And then you also need to find QLL, QLK, QKL, QKK. How to find QLL? Okay, let's go back to the Lagrangian function. QLL, you see the first one here for FL, differentiate Lagrangian function with respect to L. The first one here is you differentiating production function. The second one here is you differentiate the lambda and constraint function. This is not just a constraint or cost function. Yeah? This is including lambda. Okay, so the first bit here, when you differentiate with respect to L, is this one. So this bit before minus sign is actually QL. Q subscript L. Okay, so in order to get QLL, you differentiate this again with respect to L. Okay, when you differentiate this again with respect to L, okay, so here QLL, then you get what? Minus 168 times L minus 1.3 to the power of minus 1.3 times K to the power of 0.3. Make sure you know how to get minus 168. Now let's go back to this. When we differentiate this once again with respect to L, it means 0.7 times 800 times minus 0.3. That's why you get minus 16, okay, minus 168 here. And then how to get to the power L to the power of minus 1.3? Because from here, when you differentiate this once again, this one becomes minus 0.3 minus 1. That's why it becomes minus 1.3. Okay, K stays the same because you are not differentiating K. Now next, do the same for QLK. Okay, if it is QLK, let's go back to this. That means, okay, let me erase the mess up here first. That means you differentiate this second time. After you differentiate it with respect to L, you differentiate this with respect to K. When you differentiate it with respect to K, you are concerned about this, not this. This becomes constant, isn't it? So when you differentiate it, it becomes like this. 168 positive, yeah? Times L to the power of minus 0.3 times K to the power of minus 0.7. Okay. So in this case, how do you get positive 168? Because from here, 0.3 you bring down, multiply by 0.7 and also 800, you get positive 168 here. L no change, but K, why it becomes to the power of minus 0.7? Because from here, 0.3 minus 1, it becomes minus 0.7. Okay. Next, you do the same for Q, K, K, Q, KL. Okay, here. Q, K, K. You're gonna get minus 1. Okay, minus 168 times L to the power of 0.7 times K to the power of minus 1.7. Make sure you know how to get minus 1.7 for K. Do the same for QKL. How do you get all of this? No longer from the first equation of FOC, but you do it from here. Second equation of FOC, yeah? Okay, so for QKL, you're going to get positive 168 times L to the power of minus 0.3 times K to the power of minus 0.7. Okay, now you can fill in all of these results into this, and then you find H2, semi-positive, for H2. Now here, some students, what they did is, because they don't want to see L and K here, it becomes so difficult for them to calculate. Because you already know that L is 1000, K is also 1000, you can plug in into this value to get the answer. So that means minus 168, 1000 to the power of minus 1.3 times K, which is 1000, also to the power of 0.3. Then you can solve it. When you solve it, you're going to get minus 0.168. This one, show it also. You have to show it, yeah? Positive 168 times 1000 to the power of minus 0.3 times 1000 to the power of minus 0.7. What do you get here? You're going to get positive 0.168. Okay, so same goes to this. So you have minus 168 times 1000 times to the power of 0.7 times 1000 to the power of minus 1.7. You're going to get minus 0.168. So similarly for this, 168 times 1000, okay, to the power of minus 0.3 times 1000 to the power of minus 1.7. You're going to get positive 0.168. So next, what should you do? You can construct Hessian matrix. So how to construct? So here your ordered Hessian matrix becomes like this. 0 here, positive 70 here, positive 30 here, and then here positive 70, positive 30. Here is QLL. What is QLL? QLL is minus 0.168. Minus 0.168. QKK is here, also minus 0.168. This one, QLK is positive 0.168. Positive 0.168. QKL here is this one, positive 0.168. So you have constructed bordered Hessian matrix. Why it is called bordered Hessian matrix? Because it is bordered by constant. This is the border. Can you see it? Okay, I don't want to mess this. Next, what you should do is to find H2. Okay? H2 here, how do we do it? Let's move to another page because I don't have enough space now. Okay, so here, or we can simply do it here, otherwise we have to always go back to this slide because the border Hessian is in this slide. Alright, now what I can do is I try to make this one a bit smaller so that I can have more space. Okay, so our H2, how to do it? Okay, you see here, let's say I use the first row here. Okay, so when I use the first row here, I'm using number 0, 70, and 30. Okay, number 0, I don't have to use it because anything multiplied by 0 will be 0. Okay, so I just use 70 and 30. So for 70, you look here. Okay, then I take the minor principle 70, 0 0.168, 30, and minus 0 0.168. So here you can see 70 is in the middle. I put minus sign because this one is positive, isn't it? Minus positive. Okay, then I put square bracket. What should I do? We take 70 and this number, you do it this way. 70 times minus 0 0.168. Okay, clear? After that, okay, let me erase this. You take this one and this one. Can you see? What should I do? Put minus here. Put minus, then I have 30 times 0 0.168. Can you see? Okay, then I close the bracket so that the whole thing in the square bracket here is multiplied by minus 70. Okay, so we are done with that. Now, let me erase this mess. Okay, next, we look at 30. You go down like this, you go like this, then you have principal minor like this. Yes, yeah? Okay, now let me erase this so that it doesn't look like a mess. So basically, what should you do here? Here, 30 here becomes plus. So plus 30, or I should do it this way so that it's not separated. Yeah. So plus, here I move to the third line because I don't have enough space. 30, put square bracket. So you look at this, you look at this. So what you do? 70 times 0 0.168, and then, okay, take out this. Now you look at this, you look at this. What should you do? Put minus sign, so you have 30 times minus 0 0.168. Don't forget to close bracket. The whole thing inside here, once you get the answer, multiply it by 30. You get me? Okay. Now let me erase the mess. When you solve it, you're gonna get, for the first bit here, you're gonna get this 1176 plus, because we have plus here. For the second bit here, you're gonna get 504 equals to 1680. That's the answer. Let me erase the mess so that you can see clearly. Okay. Once you get that, you can see clearly H2 1680. 1680 is greater than 0, isn't it? Which is positive. This implies we have negative definite. Then we can say that Q, or production, is maximized. Clear? Okay, so we are done with question A. We are also done with question B. Okay, so when you want to do question B first, before you do ported Hessian, make sure you leave a lot of space for question A so that you can do ported Hessian. So now we have answered question A and question B for 14. Next, we move to bonus quiz. So if you see bonus quiz, a company has $4,910 available per month for advertising. Newspaper ads cost $130 each and cannot run more than 19 times per month. Radio ads cost $310 each and cannot run more than 28 times per month at this price. and each newspaper ad reaches 6,550 potential customers, and each radio ad reaches 7,550 potential customers. The company wants to maximize the number of ad exposures to potential customers. A. Show the system of inequalities that describe the company's constraints and objective function. B. Draw the feasible region for the system described in A. Label the appropriate coordinates. Okay. So first, you need to understand the question here. The overall, story of the question is that if you see here, this company, okay, is producing advertising and also newspapers in terms of newspaper and also radio advertisement. Okay, so it wants all of its advertisement can reach customers. So when we say can reach customer, we are talking about the advertisement exposures or ad exposures. If you are the company who are, making advertisement, of course you want as many possible as you can. I mean, in terms of customer who can see your advertisements. So can you see your objective here is you want to reach as many as customer as you can so that they can see your advertisements. Okay, so you want as many as you can means you want the more exposures to them. So as much as you can reach as many as you can, or you can maximize the number of exposures. So try to understand the story first. So in order to reach customer, you have to create advertisement. Now in this case, this company has two types of advertisements. All right. So advertisement using newspapers and also radio. And to produce advertisement, it needs cost. And the total budget that the company has is 4,910. And each newspaper ads cost 130, the price of newspaper advertisement, and the price of radio advertisement is 310. And then the company says that it cannot run more than 28 for radio advertisement, cannot run more than 19 advertisement for newspaper. Less is okay. All right. And then it says that newspaper can reach 6,550 potential customer. Potential customer for radio is 7,550. But you just want to have more exposures to them. That means you know that in the market you have 6,550 that can reach newspaper, those who always read newspaper. But not all of them will see advertisement on newspaper. They may flip the newspaper. They don't want to see the advertisement. They just want to read the news. You get what I mean? But if you can make a very interesting advertisement in the newspaper, possibly all can see the advertisement. All are interested in reading the advertisement. Out of these 650 could be like, maybe all, maybe half of them or whatnot. But as much as you can, you really want to make sure that as much as you can, up to 6,550 for instance, isn't it? So same goes for radio, which is 7,550. But in terms of exposure, it could be how many times they see the news, the advertisement. It's not about how many customer. All right. So that's the idea. Okay, now so we need. You see here A, show the system of inequalities that describe the company's constraint and objective function. The constraint here is in terms of your budget of having newspaper. Okay, so in this case, we write the constraint first. Let's say the price of newspaper is actually here 180 given in the question, and the price of radio advertisement is actually 310, which is more expensive. And then both of them cannot be run more than 28 times. It's like, if you have advertisement on radio for per month, you can have it being repeated on radio for 28 times maximum. That's what it means. So for newspaper, you can print the same advertisement for your product, not more than 19 times per month. Okay, could be twice per day. The remaining 17 could be once a day, as long as it's not more than 19 times per month for newspaper. That's what it means. That's what it means. Okay. Now, so write the constraint. So budget constraint here is actually 130, newspaper plus 310 and radio. So here N is the number of newspapers at, and radio R number of radio at. Okay, equivalent to 4910. And then another constraint is we know that it is 19 for newspaper, cannot be run more than 19. If you see the word here, cannot more than 19. 19 is okay, less is okay, but 20 is not okay. So that means newspaper advertisement cannot be more. That means less or equal to, but should be more than 0 or not 0 at all. Okay, that's the first constraint. The second constraint is radio, less or equal to 28, because maximum is 28 times, but more or equal to 0. So number 1, number 2, number 3 are the constraint. And the objective is to reach as many exposures as the company can. The exposure here, so you have 6550 for newspaper times how many times advertisement of newspaper plus 7550 times radio equivalent to the number of exposure, where Z is the number of exposure, isn't it? Okay, so this one maximize. So this is objective function constraint. That's it. Okay, next. B. Draw the feasible region for the system described in A. Label the appropriate coordinate. When you want to draw the feasible region, so here, oh man, so we have this. And here, the news is here, the radio is here. So we know that from here, maximum for news is 19. 0 is here, let's say 19 is here. Less is okay, going to the left is okay, to the right cannot, so that means you draw a vertical line. So that's, sorry, this one, this is not very straight anyway. Okay, so this one is n equal to 19 on this line. So if n is less than 19, is here. Okay, this one is n less than or equal to 19. So if radio here, if you see, cannot be more than 28. Less is okay. Radio is on vertical axis, so 28 is here. Then we do this. It's not straight. Then we do this. So here, radio is equivalent to 28 on the line. So if we are talking about below 28, it is here. So we only take positive value because you know that the constraint number of ads cannot be negative. So we don't shade the negative area here, here, and here, yeah? So when I do, this basically are less than 28. Okay, now We have another constraint, which is 130n plus 310r equivalent to 490. So we need to draw this constraint here. So how do we draw it? So here I write it again here, 130x plus 310y less than 4910. Okay, x here I change it to n, y here I change it to r. Okay, so we need to left r on the left hand side, the rest on the right hand side. So this is how we do it. 310r less or equal to 4910 minus 130 n. Okay, then you rearrange it so it becomes this. Sorry, 310. 310. So it becomes r less than. You see here, I don't change the sign. If I put it equal, later I'll show you how to put it equal so that we can draw the line. Okay, so here it becomes, okay, 15.8387 minus 0.4194 n. Okay, less than. Now from here we need to find, because this is not very straightforward, you have to draw the line. We need to find the intercepts. So the first one, vertical intercept. So when you set n equal to 0, then your r is 15.8387 minus 0, isn't it? Because this one 0 times 0.4194 is 0. Okay, minus 0, so it becomes 15.8387. So your coordinate for vertical is actually 0, 15.8387. Number 2, you need to find horizontal intercept. Horizontal intercept is where you set r equal to 0. So when you set your r equal to 0, you calculate the same way, like using this equation. Then you're gonna get n equivalent to 32.06 to 1. You have to show how to get 32.06 to 1. Yeah, here I just jump it because I'm expecting you know already how to find it. So basically what I did here in order to find the intercept is I made it r equal to 15.8387 minus 0.4194 n. Okay, to draw this curve, we also need to check the slope. So what do? Delta r over delta n. So you get minus 0.4194, yeah? 4194, which is less than 0. So we know that it is down sloping. You take the second derivative. Why? Because you want to check whether it's straight line or not. Then you get what? 0. From here, you differentiate because you don't see n, you get 0. Then it's linear. Now, you have the vertical and horizontal intercept. Horizontal intercept is basically 32.0621, 0 for the coordinate. Okay, so 32 is above, 32 is here. Okay, so the coordinate here is 32.0621, 0. Okay, and then this one is actually, but before that, let me finish the line first. And then another coordinate is 0 and 15. 15 is here because 15 cannot be more than 28, isn't it? So here 15.8387, 0. This is another coordinate. You join these 2 points. Oh man. you join these 2 points to get this curve. Okay, on the line here is actually 130 R, 130N, yeah, plus 310R less than 4, equals to 4910. So the area below, is actually, how do we know below? Because we have rearranged it like this, then we know it's below. Okay, is this area. Okay, so but then if I draw the feasible region properly, then it looks like this. Let me redraw it nicely. And R, R equal to 28 here, N equal to 19 here. Then I have this. Okay, so here, this one, 19 comma 28, the coordinate. Okay, this one is N equal to 19. Okay, so this one is 28, this one is 0. Okay, this one was, what was that? Coordinate here is 32.061 and 0. This is the coordinate. Here it is 0 and 15.8387. Okay, so and this one we need to find. After this I'll show you. So this is the feasible region. Cannot be this area, because the limit of the cost is here. Okay, and then here is actually 19, 0, the coordinate. So you have coordinate here 0, 0. You have this 0, 28. You have this, but you need to find this. Here, how to find it? Here you can see n equivalent to 19 intersect with this function. This function is actually 130x plus 310y equals to 4910 on this function. So at this function, this point, n equal to 19, so you just need to substitute this is x. You just need to substitute n here equivalent to 19 in order to get what is y here. So here, when 130n plus 310y equal to 491 is actually equals or intersects n equal to 19. So here your y, you need to search it, yeah? Your y, it's not your y. Your r is actually what? You need to find your r. How to find your r? Just substitute here n equal to 19, then you rearrange, you can get your r. Your r here would be 7.871. You have to show how to find this here from here. How do we know that it is 7.871? Because we know that when we see this curve intersect this one, then we just do the calculation. Okay, so here it becomes 19 and 7.87 1. Okay, 871. Now we need to have question C. Question here, calculate the number of each type of each ad the company should purchase to achieve maximum number of riches for this group of men. Okay, now we have found the feasible region. Therefore, from this feasible region, you look at the point of boundary. Okay, let me highlight. The first point is this, the second point is this, the third point is this, the last point is this. Okay, and we know that the objective is to achieve the maximum number of exposure. And if you look here, maximize Z. Okay, so let me rewrite it again here. So we have maximizing, okay, Z equivalent to 6550, n plus 7550 r. Okay, so we have four possibilities. Okay, the first one is here. Don't choose this, don't choose this. Don't choose this because it's not on the boundary of feasible region. If you choose here, any point here, it's not maximum because it could be here, it could be here. You get what I mean? So we choose the corner point of the boundary. So here we have the first possible one, which is 0, 0. The second one, which is 0 and 15.8387. Where is it on the graph? Which is here. Okay, this one. And then the third one is 19 and 7.8. This is the coordinate, yeah? 7098. The fourth one is 19 and 0. So how do you find it? It's actually you use Z equivalent to 6550, substitute n equal to 0, 7550 substitute r equal to 0, then you get 0. Okay. The second one, Z equivalent to 6550 times 0 plus 7550 times 15.8387. Get the answer here. Okay. And then it's going to be 119,582.185. The third one here is at 6550 19 times 19, 7550 times 7.87098 equals to, okay, 183,875.806. Okay, the last one here is at 6550 times 19 plus 7550 times 0, you're going to get this one, 124,450. Okay, out of these four possibilities, check the highest answer. The highest answer is this. So the question here says, calculate the number of each type of each ad that company should purchase to achieve maximum number of riches for this group of men. So the type of each ad. So you have N, you have R. That's the question. Okay. So first, in order to find how many N, how many R that can maximize the number of exposure or riches, okay. So we need to do 1, 2, 3, 4 here. Get the maximum one. So the maximum exposure, maximum number of riches is 183,875.806. But the question asks you how many N, how many R that can maximize this one. So how many N, how many R is actually 19 and also 7.87098. So the answer you should write, okay, let me write it here so that it becomes clearer. Maximums number of riches is actually 183,875.806. But how many N? N should be 19 and R should be 7.87098. This is the answer. Okay, clear? All right. Exercise so that you understand better the concept of derivative. Given the following function, fn equivalent to minus 2n squared plus 4n plus 10. Find the values of n for which fn is increasing. Fn means this function is increasing. How do you know whether it's increasing or decreasing? Increasing means what? Upsloping. Decreasing means what? Downsloping, isn't it? In order to do this, remember when I told you to draw graph and whatnot, increasing, decreasing, downsloping, outsloping relates with the first derivative of the function. So that means in order to find it, you have to calculate the first derivative of this function with respect to n. So let's do it. Take the first derivative of fn with respect to n. Also can be rewritten as d delta f over delta n. You can write either one of this. Okay, so you take the first derivative, so it becomes minus 2 times 2, 4, n, isn't it? N, because now 2 minus 1 becomes 1, so it becomes n plus 4. Okay, so the answer will be minus 4n plus 4. Now, whether it's increasing or decreasing, we have positive 4 here, we have minus 4n. Whether the answer here is greater than 0, because greater than 0 means increasing, isn't it? Whether it's greater than 0 or not depends on the value of n. Okay, so now, if we want to have fn increasing, then fn increasing, then set the first derivative that we found here, f prime n equal to minus 4n plus 4 greater than 0, because we need to have slope upsloping. Okay, so set is greater than 0, therefore it becomes what? 4 greater than 4n. You rearrange it. Okay, then I move here, then it becomes 4 over 4 greater than n, or n is less than 1, isn't it? So the value of n, which leads to n which is increasing, is n less than 1. Here we don't have limitation of n here, because it doesn't say that n has to be positive or negative, so n can vary between minus infinity to infinity. So that means as long as the value is less than 1, or it can be 0, can be minus 1, anything, n will be increasing. Now, just to show you more a clearer picture here, all right? So how does the curve look like basically? So when you have f prime n, which is equivalent to this, or can also be rewritten as 4 minus 4n, okay, it can be equal to 0. When it is equal to 0, that means it is either at maximum point or minimum point, isn't it? It can also be greater than 0 or less than 0. It can be greater than 0 when n is less than 1. That means greater than 0 means increasing, set n less than 1. That means this is additional note which is not answering the question, yeah, but I just want to give you a broader idea. N greater or equal to 1, that means f prime n is decreasing, isn't it? So that means n is the point in which, n equals to 1 is the point in which the optimal level, the changing point of increasing and decreasing. So in the form of graph, it will look like this. So if I have, in the form of graph, so if I have n here, fn here, 0 here, n is 1, 1 is here, okay? Anything below n, increasing. Anything after n, decreasing. So increasing must look like this, isn't it? Decreasing must look like this. So at n equivalent to 1, it will be flat. But I don't know whether it is here or here. You get what I mean? So we need to decide whether it's here or here. How to decide it? Then you need to find the value of fn also. You know that n is at this point, n is equivalent to 1. When n equivalent to 1, fn is what? Fn is, use this function, substitute n equivalent to 1 to times n equivalent to 1, right, square plus 4 times 1 plus 10. So it's going to be 2 times 1, 2, 2 plus 4, 6, 6 plus 10, 16. Okay, so the coordinate here is, 1, 16. 1, 16, let's say 16 is here. So it may increase like this. Okay, and then this one what value? This one what value? Could be here. I don't know. You have to decide the intercept. So this is just to show you the broader idea about what does it mean by this function. But the answer for this is up to this only. This is just to show you the broader idea. So I can easily change this question. Instead of increasing, I call it decreasing. So if it is decreasing, you have to set f prime n, less than 0. So change this to less than 0. Then it becomes less. Then it becomes this. Then it becomes this, isn't it? Which is this. You get me? So when n is equivalent to 1, you reach the maximum point. And this one, in mathematics, we call it vertex. Is it clear? So you try as many as you can, yeah? In terms of, understanding this. I can also give you another example. Let's say I give you this equation. Okay, gx equivalent to 3x squared plus 6x minus 100. Can you do the same? Find the value of x for which gx is increasing, or find the value of x for which gx is decreasing. The same thing. Okay, all right. So that's all for the revision of quizzes plus some other things here that I have added. So try to do whatever exercises that I strongly advise in the lecture and also in the videos. So good luck for the exam.